Intermediate Algebra Mid-Course Assessment, questions 17, 18, and 19. In question number 17, we're going to go ahead and factor. Now, when I look at this one, I could, because I have something in the A position, use the A times the C method. That means I would take the 9 times the 16, then whatever number I've created, I would look for factors that would make that number that would sum to the middle term, which is the negative 24. But there's also something else about this problem. If I look at it, the A position can actually be squared. It's 3 to the second power, as can the C position. It's 4 to the second power. So if I look at the problem, if my bases in the A position and my base in the C position multiplied to a 2 equal back to this negative 24x, then I have a problem where I have the A squared minus 2b plus b squared, which means I can just write this as A minus b, the first position minus the last position squared, and be done with my factoring. Now the A times C method will get me to the same answer. So I see this, I can look back here, my 2 times my 3 gets a 6, 6 times 4, 24. So I have a minus 24x to the middle. So I can use this shortcut here if I remember my formula. So I take the front position, the 3x, and plug it in, 3x, and I take the base of my last position, and it's minus whatever that base is, in this case is a 4, and plug it in. And then it's overall squared. Now let's move on to number 18. This one says in its instructions, solve using the zero factor theorem. So I already have a problem here that's been factored. I have an x minus 5 times an x plus 3. What I'm going to do is take each one of these and set them equal to 0 and solve. So I come over here, the x minus 5 equals 0. I'm going to sum the 5 to both sides so that I take this 5 on the left down to 0 so that I'm left with x equals 5. On the other side, do the same thing. Take the x plus 3 and equal it to 0. I'm going to subtract the 3 off both sides so that the 3 goes down to a 0 on the left side, so I'm left with just the x equals a negative 3. So my answer here is 5, negative 3. Do not put these answers into parentheses. Remember, the parentheses are going to be for ordered pairs, and we're not dealing with ordered pairs at this time. So it's just going to be the answer with a comma in between the two answers, or 3 answers or 4, however many you end up with. Alright, number 19 just says to solve. So looking at this one, we're going to do the same thing. We're going to factor this thing out. We start with the greatest common factor. I see I've got a 5, a 30, and a 40. They're all divisible by 5. So I'm going to divide a 5 out of everything. So a 5 into an x squared leaves me with x squared. A 5 divided into a 30x leaves me with a negative 6x. And a 5 divided into 40 leaves me with an 8. Coming down from there, I'm now going to take what's in my C position, or my last position, which is an 8, and look at what's in my B position, or center position, which is a negative 6. I want factors that will create a positive 8, but when summed, create a negative 6. So knowing that, my factors to create a positive on the first one are going to both have to be negative. A negative times a negative makes a positive. So a negative 1 times a negative 8 equals 8. Well, negative 8 plus negative 8 equals negative 9. I want a negative 6, so that one's not correct. So I move on to the next pair of factors that will get me to an 8. So a negative 2 times a negative 4, that makes a positive 8. A negative 2 plus a negative 4, that makes a negative 6. So that one works. So I'm going to come down here. I'm going to copy down my 5 that I factored out earlier. I'm going to set up my pair of binomials with an x in the first place on each one. Then I'm going to come back and take those factors that I found and add them into those binomials. So I'm going to add on to that x a minus 2. I'm going to add on to that x a minus 4. Now I have this thing factored. So now I can set it up. So I'm going to take every one of these terms, this term here, this and the two binomials, and set them equal to 0 and solve. Well, 5 equal to 0. 5 is not really equal to 0. Okay, so that one just canceled out on me. Then I have here a x equals a 2. So a plus 2 plus 2, so I end up with x equals 2. And I end up here adding a 4, so I end up with x is equal to a 4. There are my answers, 2 and 4.